Hi, this session is continuing with Pythagoras' theorem, and now we are finding the length of the shorter sides. We've learned how to find the length of the hypotenuse, which is the longer side, so now we will be finding the other sides. Now, just to quickly recap, Pythagoras' theorem always relates to a right-angled triangle. Okay, so this triangle has to have a 90-degree corner, and the hypotenuse is always opposite the right angle, and it's always the longer side, the longest side. That's what we call the hypotenuse. So it's the longest side opposite the right angle. And the other two sides are always shorter. Now the hypotenuse, we always use the symbol C. So this length here is always C. The shorter sides can be either A or B. So I can say this one's A and that one's B. Or you can have it the other way around, doesn't matter. But C is always the hypotenuse. It's really important. And now, just to make sure you understand what this whole theorem states, is if we have a right angle triangle, let's clear this. If we have a right angle triangle, and I put some measurements in, just say we've got 5 centimeters here, 3 centimeters here, and 4 centimeters there. So that's the length of each side of this triangle. If I square the hypotenuse, 5 squared would give me what? 25 centimeters squared. If I square the 4 times 4 is 16 centimeters squared. And 3 times 3 is 9 centimeters squared. Okay, that's squaring the length. So squaring the length of each side. And you can also show this as a square, because a square we know has all equal sides. Okay, so all sides are equal, the same length in this case as the hypotenuse. And we know the area of a square will be 5 times 5, which gives me the area of 25 centimeters squared. And the same thing down here, I have a square, okay, length of 4 centimeters, and its area is 16 centimeters squared. And this square here, 3 times 3, all sides are equal, gives me 9 centimeters squared. And that theorem states the square of the hypotenuse, so this line here, when I square it, okay, is equal to the sum of the squares of the other two sides. Sum means we add them. So if I look at these two squares and I add them, so I've got the area is 9 centimeters squared and this area is 16. 9 plus 16 gives me my 25 centimeters squared. Okay, and there it is. So the length, so once again, the square of the hypotenuse, or this square here, see it visually, is equal to the sum of the squares of the other two sides. So this square plus this square gives us the area of this square. Okay, and that's just showing it visually. And if you're still not sure, just come and let me know. Now, just to recap on a previous lesson that we did in class, in case you were away especially, knowing this theorem, we can now find unknown side lengths of a right angled triangle. And in this case, C is the hypotenuse opposite the right angle. And the formula is C squared is equal to A squared plus B squared. And all this is saying is if I square the hypotenuse, there's the square, it's equal to the sum of the squares of the other two sides. Okay, and that can be A, that can be B, and there's C. So now we just substitute these values into our formula. We don't know what C is. We're trying to find the length of C, the hypotenuse. That's what we're trying to find. So we have C squared equals A is now 5 squared plus B is now 2 squared. So then we have C squared is equal to 25 plus 4. We add those. C squared is equal to 29. And of course this part may be new to some of you. To get rid of this squared, the opposite of a square is to square root it. That cancels out, but we must square root this other side. Okay? Now, so far we have C is equal to the square root of 29. Now, the square root of 29, unfortunately 29 isn't a perfect square. So this is what we call a surd. And I don't think we can further simplify this surd either. Always check and see if you can simplify the surd. Now, if the question asks for an exact answer, that's it. Leave it in surd form. And this question did ask for an exact answer. But just say it asked for an approximate answer, so approximate answer, you would have to get your calculator and put the square root of 29 into your calculator. And the question should ask you to round it off, for example, to 2 decimal places. So I would end up having, now approximately, I should actually use the approximate equal sign, to 2 decimal places, 5.39. And that would be my approximate answer. So just remember, exact means leave it in third form, approximate, round it off to whatever the decimal place they ask you. Okay, so that will be the answer for this one. Now, if you look at our second example, you can see that with this question, the hypotenuse is given to us. Hypotenuse opposite the right angle is 17. So C is equal to 17. We have to now find the length of a shorter side. In this case, we have to find what they call this side is A. So we can say now B is equal to 15. We are trying to find A. Now, first step, write the formula. C squared is equal to A squared plus B squared. And now substitute the values that we have. So C is 17 squared. Now, A squared, we are trying to find A, so A squared is still there, plus B squared, but B is 15. Now, once you have substituted the values in, you have to solve for the unknown variable. Instead of C now, we have to solve for A squared. Now, if you don't like working with your variables on this side here, just stop and rewrite it. So I have A squared plus 15 squared equals 17 squared. I have not changed my equation. I now have my A on the left-hand side. If you don't mind working with the variable on the right-hand side, then keep going, that's fine. Now, I'm going to subtract the 15 squared. If you want to evaluate your values, you can, or you can leave it till later. Up to you, but I'll leave it till later. So I have to do I have to solve for the A. So minus 15 squared and minus 15 squared. So I now have A squared is equal to 17 squared minus 15 squared. And now I'll evaluate 17 squared and minus the 15 squared. Just continuing up here. We now have, so A squared is equal to 17 times 17 is 289, minus 15 squared is 225. And now we just work this out. So A squared will equal to, what do we get? 64. Sorry, it just froze. We're almost done. Now A, we've got to get rid of that squared. So the opposite of the squared is to square root it. Cancels out. Make sure we square root 64. And so we have A is equal to, now is 64 a perfect square? Yes, it is. So the square root of 64 is simply 8. So we have a rational number. So it's not a third, it's just A equals 8. And that's it. Now we weren't given any measurements in that question. Just keep that in mind. If this, just say we had centimeters, we'd have to put centimeters there. But the question had no measurements, so we can stop there. And we have found the length of the shorter side. So we have found, if you remember, A was on this side here. So now that side has a length of 8. For our next question, instead of A or B, they've given us the side, they're naming it X. So don't be confused by that. We can use other variables if you want to, okay? But as long as you know your formula. So the formula is C squared is equal to A squared plus B squared, okay? So the hypotenuse is your first step, opposite the right angle. C is equal to 10. So we're not trying to find the hypotenuse, we're trying to find a shorter side. I can say A is 7.6, and I can say B is equal to X, and I'll just sub everything in. So let's do that. So C is now 10 squared, A is 7.6 squared, plus, instead of B, we'll use an X. So it's still a variable that we're trying to solve, but we'll stick with the question's variable. And now we just solve this. Because I don't like my X on this side, I'm going to rewrite it. So I have 7.6 squared plus X squared equals 10 squared. I have not changed anything. Now I'll minus the 7.6 squared, it's positive, and minus 7.6 squared. So I'm left with x squared is equal to 10 squared minus 7.6 squared. And now 10 squared, let's evaluate to show the value, is 100 minus 7.6 squared gives us 57.76. Oh, sorry, what was it? 57.76. Okay, and then we just chuck that into our calculator, and it gives us x is equal to 42.24. Okay, and don't forget the squared. We're almost there. I'll just continue it up here. So we've got x squared is equal to 42.24. And our final step, of course, get rid of that squared. So we have to square root it, cancels out, and square root it. So we now have x is equal to the square root of 42.24. Now, I can check and put that in my calculator. Most likely, it will be a third. Let's just check 42, the square root of 42.24. Okay, now if the question said leave your answer as an exact answer, there it is. I stop here, insert form. Approximate answer, I'd have x is approximately equal to, round this off, we end up with 6.50 or 6.5. Okay, so, and that's it. So I've put both answers here. Exact is here and approximate is there. Always read the question.